Okay, so as Anup sir introduced, this is one of the technology which is used in the IT industry to integrate different tools. Right, like we have a developer, right? So we'll see one by one. Okay, so this is some agenda. I will cover one by one all this agenda, and we'll see how this technology is used in most of the IT industry. Okay, so first of all, we'll see what is the software development, then a software development life cycle, and what is DevOps, and DevOps life cycle, and different tools. And if we have any query, we'll address that. Okay. First, what is software development? So, as you all know, like we have in IT industry, so we all are working for the any software development or a website development for different requirement from the client. So that as a team, we as a team we work in a team so that we can create any software, any website. So this is the software development. Software development is the process of transforming customer requirements into a complete software product. So we have different clients which has their requirements, which have their products for their requirements. They ask us like they ask us any company to develop anything for them. So for that, this is the software development. So for developing any software or any website, there are different life cycles. So as a team or as an IT company, they need to follow some steps so that they can create their software or website as a in a proper manner as per their client's requirements. So what is the software development life cycle? So in a broader term, a software development involves the following stages. Like first is like requirement, design, implementation, verification, and then the verification and the like feedback. So what is the requirement? Like if I am a client and you all are at TCS or whatever the team, like a Python Academy. So I am a client and I want to develop any software, any web server. So I have a requirement that I want to develop a e-commerce website. For that, I require this kind of UI, which is like so any customer visit that web server or website. So it should be like this product I want to buy. So the end user should see like this kind of products. They should be in a UI so that I can buy it. So this is the requirement for me. So for that, I will hire or I will like contact some of them you or as a company head so that I want this kind of requirement so that please let me know how we can design this. So after we have requirement, then we are going to design this as a IT team. Means I'm a technical person, so I know how need to develop these things in a actual manner. So design means there must be some architecture like in the solution architect diagram. So once we have a requirement, then we are proceed for the design. Once we have design, we need to plan it how we can implement this in a actual manner. So let's say suppose we have front end, back end team, then database team. So everyone should know like what is the architectural diagram we have designed. Then after that we need to implement it as particularly like okay. So front end developer should develop a front end design like how UI will be work as so that end user will visit that site so that they will see okay this kind of UI we have. So if we click on any product, it should open its description and anything. Then backend development, so they will manage all the database connection. Then UI, API cloud, API connection. Then if they need to manage a server, so this kind of implementation will distribute in amongst different teams. So after that, it's verification. Okay, we have design, we have requirement, and we have also a implementation. Then implementation team they are going to implement it. Once they implement it, then customer needs to verify it. Okay, these are my requirements, and okay, they will verify. Okay, I need this kind of UI, this kind of backend, this kind of design. So okay, if I get this, it will be if he verifies, then we are going to release that particular project or a site or any website to the for the customer end. So this is not nothing but the life cycle of software development. So to implement this SDLC means software development life cycle, we need to follow some set of models. So models are nothing but since the time software development started, various software development models have been curated which implements SDLC. Which of these models solve problems that existed before these models were invented? That means, okay, we have implementation, we have design, but how we are going to manage it, how we are going to plan it. Okay, so for that we have traditionally, when started when in IT industry we have started this software development or website development. These are some traditionally two major software development models we were using. One is waterfall model, second is agile model. So we'll see one by one, and after that we will understand where this DevOps come in initial stage. These all are some waterfall. These are some models for the SDLC. The first is waterfall model. So waterfall model was among the first development models which followed SDLC. So at the initial stage, this kind of waterfall model or this kind of software development life cycle we were using. So in that, what is happening, that waterfall model follows the linear sequential model of development. That is, until the first stage is not finished, the next stage will not start. So we have seen like how SDLC works, like how it is, how we are going to plan it, how we are going to implement it. First of all, first is project planning, then requirement analysis, design, and coding, testing, and deployment. These all are some steps of waterfall model. So how this waterfall model works? If you see, waterfall model follows the linear sequential model of development. That means, first of all, we need to complete the project planning. After that, only we will go to the requirements. After that, we will do analysis. After that, we will do a design, coding, testing, and development. So each of these steps will only after start when the previous one is completed. So once project planning is completed, then only we'll go to the requirement. Then only we'll go to the analysis. Then analysis. So until and unless the previous one is not completed, we will not going to start this. So this kind of waterfall model we were using earlier. The next is agile. So what is the disadvantage of waterfall model is that we need to wait until our last stage is not completed, right? So we need to first complete the design, then only going to start a coding or development. So for that, client needs to be completed the whole feature of whole project. After that, they will get their end project, right? End product. So for that, this is the one of the biggest disadvantage of that. So it means we are not delivering our product very fast. They need to wait it until the whole project or whole feature is not released. So to overcome this thing, they have next model is agile method. So if you see here, to overcome the challenges faced in the waterfall model, we come up with the agile methodology. So agile methodology believes in creating a shorter development life cycle. That means in waterfall model, what we did, until and unless the last one is not completed, we are not going to start the next one. But here it is not like that. We are going to like shorter development life cycles are achieved by not releasing all the features at once, by following the incremental model of development. You'll see in the next slide, you will definitely understand. Okay. If you see the waterfall model, first the orange one is requirement. Okay, we have requirement, then only we start a design, then implementation, then verification, and then release, and then it will be release and get a feedback from the customer. Okay, so this is the waterfall model. But if you see in the agile model, this is a short term of feature. Like we are not going to completely work on it one task. We'll break it down. We'll get a requirement first for the small feature, then design it, then implement it, verify it, and then we are going to release, and then we'll get a verification. Okay, we got a customer feedback for this small thing. Means, let's suppose I have give you example as an e-commerce website. For that, if suppose client wants, there is one UI where some shirts are going to deliver, or if you click on in shirts, it should be open all the features of it, like its pricing, then what its sizing and everything. So we'll deliver only these things. We'll get a requirement for the shirts, then we'll go to the design, implement it, verify it, and if it is okay, then we'll go to the next step. Means we have divided the whole project in a short terms, so that we'll get a feedback from customer easily, fastly, and we'll deliver it the short amount of projects to the client, so that we'll get a good amount of features. This is the difference between waterfall versus agile. So if you see waterfall with problem with waterfall model was the development lifecycle took a lot of time to complete. Therefore, by the time finished product was delivered, the customer requirements were no longer the same. Means we are taking like plan, means we are following the whole life cycle, whole model that comes at the end. When we deliver the product, might be the requirement of client get changed, because we have took 2 months to deliver them one product, right? So at that time, maybe they require some more features. So for that, then we need to again start from the first. So instead of this, in agile model, what we did, uh, this problem was fixed by the agile methodology. So this methodology strictly focus on a customer feedback. So we deliver them a short amount of features, so that they get, so we get a feedback from them, and so that we have deliver them software which is a quality software. That means whatever they require, we have provided them, and they are happy with the new features. So if you see that methodology strictly focus on the customer feedback and improving the software quality, that too in a shorter development life cycle. Next thing. So okay, these all are some models which we see. So where this DevOps comes in the picture, like okay, we have two methodology. Agile is working very properly. Means we are getting feedback from the customer, so that we are good with our product. So now, then why we required to implement this DevOps, and what is the DevOps? Okay, although the software quality was improved, okay, we got feedback from the customer, so that we are improving our code and releasing our product to the customer, so that they are happy with that. But but we still had a lack of efficiency among the development team. So as I earlier mentioned, that we have long big team of software operational team. Then there are some team leaders, testers. So in among team, we have to manage that. Like typical software development team consists of developers, operation employees, and okay. So we have developers and operations team. We'll understand what is the development and okay. Developer's job is to develop application and pass his code to the operation team. And the operations team job is to test the code, provide a feedback to developers in a case of bugs. If all goes well, the operations team upload the code to the build server. So developer is going to develop a code, like he's a backend developer or front end developer or anything. He's going to develop in a Java, Python, everything, anything. So this is the one of the tool, like Git. It's a it's a version control system. But as I earlier explained, what is the version control and why we required it to implement in our project. Okay, what is the Git? So Git is a version control system for tracking the changes in the computer file and coordinating work on those files among the multiple people. It is primarily used for a source code management in a software development, but it can be used to keep track of changes in any set of files. So Git is a kind of tool, or we can say it's a framework which we are going to install in our system. So using that Git, we track our versions of the different tools. We'll understand from this, so that you will get okay. So we have a, so this is my system, my local system. I have a code. I've created some set of let's say directories. So inside that directories, I have initialized the Git. Means I have installed it. If you go to the Git, you will on a Google, you will definitely get a Git framework, Git software, which you need to install in your local system. So for that, we need to initialize that Git. So if you run the Git init command, you will get all the libraries inside that workspace. So after that, once you initialize that workspace, you will going to stages the files in the working directory for a commit. Means if I write a code, means I write a Python, whatever one script for the Python. So I want to push it to the centralized repository, means centralized space where I need to manage all my projects code or scripts in a one place. So for that, I will use that this Git. Once I do a Git initialize, then I will stage that files in a space. Then I will commit that files or a script in a GitHub. So GitHub, like if you go to this GitHub.com, you will get a centralized repository like this. This is the GitHub account or GitHub window you can see. So inside this, you need to create your account. Then you need to create this GitHub account. After that, you can create your own repository. Means this is the centralized. Means if anyone has in a team, if we all are working in the same team, we can easily access this GitHub and see when the last code was pushed, when the last updates were done. So 3 days back last week. So we can see the different versions in the same GitHub page. So for that, due to this, we are good to control the versions. Like, okay, last week we have committed this, then we have to clone the latest code so that we can work on it and proceed for the next feature. Okay, so these all are some git commands. So git init to initialize the git working directory, git status to check the file status, then git add. So if you want to add these files in a stage, means there is one virtual space, we can say, where we can add this file. After that, after running this git commit, we can push our whatever the files we want to push to the centralized GitHub repository. We can push it using the git push. Then to clone it means, if she is a new developer in my team, and I want to give a repository, a complete set of code to her. So what she will do? She will install the Git in her system. Then she did just run git clone and the URL of this GitHub repository. If you click on this code, you will get a HTTPS URL for this repository. So if you run this git clone and then this particular GitHub URL, you will get all the GitHub repositories code in your system. Okay. Then Git branch. There are different branches we need to create in a GitHub, like dev feature master. So here, like in a real industry, what we did, if we have three environments, like stage, development, and a master, means a production. So development is for us, which is working for the local things. We are working for the development, right? So for that we have a development environment. Then a stage environment for where we need to test that things on a real time. It is the same thing, like mass production and a feature are the two similar environment where we test. Okay, this is our website. We are going to push it to the feature environment, means, sorry, the stage environment, and we will test. Okay, this kind of development we have completed, and if it is working properly, then only we'll push it to the production. So master branch is the end of the our project, means it is the final code of the project. Next is continuous integration. Okay, so okay, we have seen that from local we are going to push our changes to the GitHub. It's the centralized. Okay, but after that we need to integrate this GitHub with the different tools which is available in our GitHub module. So what is the continuous integration? So continuous integration is a DevOps software development practice where developers regularly merge their code changes into a central repository, after which automated builds and tests are run. So we'll see here. Okay, so we have a developer who push his code to the centralized repository, that is GitHub. Then by using this repository or a code, he wants to integrate it with the different servers. Means he wants to push that code to the tester so that he can test it, and if it is okay, then he will provide a feedback to him. Similarly, if you want to provide it that code to let's suppose staging environment, so he can easily do it using this continuous integration. So these all are integrations will be done by the DevOps engineer. So there are different tools which is used for this integration. So what will happen? So instead of doing it manually, means we'll take code and run it to the production server or a staging server. Instead of that, we'll create one continuous integration tool. By using that, we'll push that uh, to the particular server. Okay, so these all are some tools which is popularly used for the continuous integration. First is Jenkins, then GitHub Action and Circle. Anyone heard about this? Okay, so Jenkins is a tool that is used for the automation. It is mainly an open source server that allows all the developers to build, test, and deploy the software. Okay, then it is written in a Java and runs on a Java only. By using Jenkins, we can make a continuous integration of projects and end-to-end automation. Next is GitHub Action. what we have seen that GitHub, right? GitHub repository. Inside that only we will use this integration as well as GitHub Action. GitHub Action is a continuous integration and continuous delivery platform to allows you to automate your build, test, and deployment pipeline. You can create workflows that build and test every pull request to your repository or deploy merge pull request on production. Similarly, a Circle CI again a different integration tool. So these are all CI tools, Jenkins, GitHub Action, or any Circle CI, which use a YAML scripting. So means you need to just define one YAML script. Inside that, you can just write whatever steps or whatever the jobs you want to run. It will automatically run. So there is no, we don't require to manually just trigger anything. Okay. Let's understand how it is working. First of all, this is the GitHub Action things. Okay, inside that we want to install npm or node.js, yes, node.js things in from our code. Okay, for that, first of all, name is circle here. This is the workflow file of that circle C, sorry, git action. How it will work? Trigger the workflow when pushing the code to the main branch. That means I have told you that we have three branches: main, feature, and a develop. So anyone, like if I push my code or my changes to the GitHub to the main branch, as soon as my code will get pushed to the main branch, this workflow will activate this, and that means this workflow will trigger its job. So what is the job? Define a job to be run. As soon as anyone pushes anything on a main branch, it will start the job. Means first job is to build, means it will first build and run on Ubuntu latest. Means there is one Ubuntu, what we can say, the container which will give you in a backend so that you can all install this dependency on it. Means we don't require to create any Ubuntu machine or Ubuntu server or any server. It will automatically give us one Ubuntu platform. On that, first step we'll check out the code from the repository. First we'll clone that repository on the Ubuntu latest environment. Once we have total the whole code in our Ubuntu latest, then we will set up the Node.js environment. If you see the name, set up Node.js, use action setup Node v3, and then with Node version means we are going to install the Node version inside that Ubuntu version. Why we require Node.js? Because if our code is of Node.js, then we require a Node.js, right? So after that, and it will show us which versions of Node.js we required in our system. After that, the next is install dependency. So to run any Node.js, we require npm. So for that, it will automatically then start installing the npm. So now we have a whole infrastructure or whole server where our code can easily run, and whatever action we want to perform, it will perform automatically. So there is no manually, we don't require to manually set up the server like this Ubuntu server. Then don't require to install any Node.js or npm install. So it will just integrate this with GitHub and the server. It will automatically do in a backend. So this is the integration. Then continuous deployment. So continuous deployment is a software development practice where code changes are automatically deployed to a server as soon as they pass through the automated testing and quality assurance. Continuous deployment fully automates the release process. This allows teams to deliver the new feature, bug fixes, and improvement to user, quickly reducing the time between the development release. So, okay, we have integrated GitHub with the different servers or different testing servers. But now we want to, we have built our code. Now we have artifacts. To deploy that artifacts to a particular server, for that we require a continuous deployment. To understand the deployment means instead of creating a big servers, so we have some virtualization and containerization concept in the industry. Okay, so we'll understand this first, and then we'll see how this deployment is working. So first, what is virtualization? Virtualization is the process of running multiple virtual systems or resources on a top of single physical machine. These resources could be a storage device, network, or even operating system. Means we have this we all have our system, right? We are a laptop, but if you want to, we have Windows server, Windows OS, but we want to install let's say Ubuntu on it, or Ubuntu OS. For that, it's not possible to buy a new laptop and install a Ubuntu server and use it. So instead of, we have virtual machines. You heard about this virtual machine? Okay, so this virtual machine is nothing but a virtualization. What will happen? this is our host operating system. This is our laptop. Instead, on that laptop, we will install a hypervisor. Hypervisor is nothing but which is work as a virtualization, which is nothing but a VMware virtual machine. So inside that virtual machine, we will create different servers or different OS. This guest OS means in Windows system, they have installed this virtual machine. In on that virtual machine, we have used to install an Ubuntu system, or let's say Apple or Apple OS. So this kind of OS we can install it in a same operating system. So this is nothing but the virtualization. So why this virtualization used like that? Okay, so we have a software A which is running on a Ubuntu server. Okay, which use 100% of CPU. But I have again a software which is working on a only a Windows server. Then what I will do? I'm not going to buy a new server and set up in the system. It will cost us more and it's not doable. Okay, so for that, then after the virtualization, what will happen? I have a I have a server running on a Windows, and I have a system where I have installed a virtualization, means virtual machine. Inside that virtual machine, I have created two different OS. One is for the Windows and one is for the Ubuntu. So both software A and B, which requires different OS, it will automatically use that one host system to run the different software. So then the next concept is containerization. So what is containerization? Is okay. We have virtual machine. We have installed virtual machine in our laptop, and after that, we have used different OS. Means install the different OS in it. But disadvantage of this virtual machine is that let's say suppose we have a 10 GB of CPU or 10 GB of storage. For that, we have installed a virtual machine which itself get a 2 GB. Okay, that means we have now 8 GB only. So inside that virtual machine, then we are again installing some more also OS. So we have installed Ubuntu OS, then Windows OS, then maybe on Apple OS. So for that, means every OS will get its own resources. Means 2 GB of Ubuntu, 2 GB of Windows, 2 GB of Apple. So total hardware we have 10 GB. Then we have main operating system which gets 2 GB of data. Means we have 8 GB now. Again, in virtual machine, what we did, we have installed a hypervisor. Which again it takes 2 GB. Means total 10 GB. We have already used 6 GB of storage on CPU already. Then we are going to again install some guest OS. So in that case, our main hardware or main system gets slow. If whatever we want to work on it, we cannot do it because of less storage, and it's a very cost thing. We cannot buy a new storage and RAM for this particular thing. For that, to resolve this, we have a containerization. So application containerization is an OS layer virtualization method used to deploy and run a distributed application without launching the entire virtual machine for each laptop. Means we have now hardware, means our system. Inside that we have our own operating system. Inside that we will install a containerization tools, which are different containerization tools we'll see in the next slide. So we have a container engine now. So now for that, now we are not going to install the whole OS in it. Instead of this, if we require to run a software on a Ubuntu machine, so for that, now in a containerization, we are not going to install the whole OS, means whole Ubuntu machine in our system. Instead of that, we only use the beans and libraries, means different packages we have. For let's say my application one requires only small amount of storage, Ubuntu image, and then that's it. Okay, I just want this library and binaries. So I will just install that on the in the container engine and will run it in the application. So why this containerization use and problems before this is virtualization, but this should be a containerization. Okay, so developers when run the code on their system, it would run perfectly, but the code would not run on an operation system. The same thing, which why the DevOps introduced, because of this coordination. To establish the coordination, we have a DevOps. So same thing, like developers say whatever the code I have written, it is working fine in my system. But when he pass it to the operations team for the testing team said that doesn't this code is doesn't work in on my system. It seems uh, code is faulty. Then again, he says like the developer says, well, try the VM that I am working in it. So suppose he is working on a virtual machine. So he said, okay, I will give you a password, is whatever the username and password of that virtual machine. Just use it and try it in on your system. But he said like that could be break another code on a testing production. Means instead of using the virtual machine, installing the virtual machine in his system, it is not possible because he is already working for the different maybe testing purpose, different codes. So it's not possible. So in that case, if we use a containerization tool, the same means just developer will do just create one image, containerization image. It will just install the libraries and the binary files which is only required to run his code. It will just wrap that his code or application and just send it to the operations team. Same operations team will install that things and in a system and then start testing. So this kind of useful things is using by the containerization. This kind of tools we can use to wrap up our whole code in the small amount of packages. So this is the containerization tools which are mostly available in market, but most we use this Docker. So we'll see about this Docker. Okay. So what is a Docker? So anyone heard about this Docker? Okay, so Docker is a tool that makes it easier to create, deploy, and run application using a container. So containers are lightweight and portable, meaning they bundle an application and all its dependency into one package. This allows the app to run consistently across the different environments, whether it's on your computer, a server, or a cloud. That means it's a containerization tool that we are going to install in our system so that it will create a package of it will use only the package and library of a particular to run that particular application. So it will just create that small package. That packages we can send it to any team, in an operations team or a tester, anyone. We can just download it from the Docker Hub, install it in his system, and just try to run. It will automatically runs on the system. Means it's not required to just set up the same system, same servers, same operating system or same storage or CPU which has a developer. The same thing he's not required to do it in his own system. If I'm a developer, I have a Ubuntu server, I have a 10 GB of CPU or a version storage. Then it's not required to install the same Ubuntu version of OS and CPU and all these things in the operation system. He just required to just download that Docker containers in his system. He just run it, and it will work fine. So this is how a Docker container lifecycle is. Like, this is a Docker engine. Means we have to install a Docker in our system. By once we have installed a Docker, we'll create an image from that. Means image means it's a small script or a small kind of set of commands which will have all the things which have all the commands how this Docker image will define. So once we create this image, we can just push it to the Docker Hub. Docker Hub means it's a private repository or a public repository where all these images can store. We can just download it whatever we require. Let's say suppose we want Ubuntu machine's image. So instead of installing the whole Ubuntu OS, we can just go to the Docker Hub, use Docker Ubuntu image, just install it in your system, just push it to the in your system. You can just run it. You will get the whole infrastructure of Ubuntu. Okay, so components of Docker ecosystem. So Docker, I have shown you like this is Docker image, then Docker container and Docker file. So Docker image, a Docker image is like a blueprint of or a template that contains everything needs to run on in an application, including the code, libraries, dependency, and configuration. So Docker image is a set of blueprint. It has a template. Okay, for this application, it only requires Ubuntu, then it only requires to run a web server that means so it will only has that particular blueprint or a contents in it. That's it. Then Docker container, a container is the instance of an image. When you run a Docker image, it creates a container that runs in the application. So you have created a Docker image. So to convert that Docker image into a container, that means if you that Docker container has its own IP address. So if you hit that Docker IP address, you can just see whatever the contents inside it. Means if it is a website, then you can just hit that URL with the IP, you will see all the UI and whatever the inside that container. You can easily see that. And it's a then the Docker file. Docker file is a text of file that contains a series of instructions for a Docker to build a Docker image. It defines everything needed to set up an environment to run an application. So Docker file is like this. This is the Docker file. So these all are some small set of commands. Okay, you just need to read write from Ubuntu, which is already an image in Docker Hub. You just need to require write from Ubuntu. You will get Ubuntu OS. Then run apt-get update. After we have Ubuntu, then we want to update that packages. Just update it. Then after that, if you want to run or get Apache 2, Apache 2 is a web server. So if you want to run anything as a web server, means if you want to create any website, you require Apache 2 in your system. After that, you just require to add www.html. This is the place, this is the directory inside that the index.html is placed. So if you just write this, you will get a complete image of Apache server. So if you convert this Docker image into a Docker container and run it by using, there are some set of commands, Docker run and Docker images. So if you run that Docker container, you will get the Apache web server index.html file. The next is Kubernetes. So all these are deployment tools which is used in a industry for the continuous in a DevOps platform. So this is the what is the Kubernetes? So Kubernetes is a tool that helps you to manage containers like Docker containers at a scale. It makes it easier to run and coordinate multiple containers across the multiple machines or environments. Okay, so imagine you have a website running in several containers. Kubernetes ensures that they are always up, healthy, and distributed. So we have seen the Docker containers now. So in a project, in a real-time project, it's not like there is only one Docker container, which is going to we just run it, we just access it, and we are okay. We are get whatever we want. But in a real project, we have different Docker containers. One is Docker container using for the front end, one is for the back end, one is for the database, one is for the other infrastructure things. So we need to manage this all in a using a one framework or one tool. So that for that we are using a Docker Kubernetes. So Docker Kubernetes is a container orchestration tool which is used to manage all these Docker containers. So why Kubernetes? Why use Kubernetes? As the application grows, managing containers manually can be difficult. So as I mentioned, we don't have one containers. We have different containers. For that, we need to manage that container so that our website or our software looks fine or runs fine. So Kubernetes automates tasks like scaling, self-healing, load balancing, or rolling. So scaling automatically adjusts the number of running containers based on the traffic. Self-healing restart the containers that fail or become unresponsive. Then the load balancing distributes the traffic between the containers to handle a more request efficiently. Then rolling updates the application without a downtime. These all are some features of Kubernetes. I will give you one use case. After that, we'll see the Kubernetes. Okay. So this is the one of the famous use case, Hotstar. You all know about Hotstar, right? So recently, Hotstar has like migrate their whole system or whole app in a Kubernetes. First of all, they were using the EC2 instance, which is a AWS server, but they have now migrated to the Kubernetes. So how it works? Like, okay, I have show you that it is used for the scaling, self-healing, load balancing, and rolling the updates. How it works? Okay, today we'll get example of a match. Okay, India Bangladesh match or India. Yesterday we have seen that. Okay, so today we don't have any match. So there is no traffic on a Hotstar, right? It is normal. Like day to day there are suppose only the 1,000 of users are using the Hotstar. Then it's fine that there should be one service, one pod means this is the pod means there are some all containers. Okay, so one container can handle the hundreds of users. But let's say suppose tomorrow is a match, and they know that if we have an India Pakistan match, India Bangladesh match, we are going to telecast it on our Hotstar on our platform. Then definitely there are more than 1 CR, 2 CR users are going to hit our app and use our app. So in that case, they are in that case then they know that today there is no match. So they are not going to create the different containers, different replicas today because it will cost them more. But they know that we have a match today, tomorrow, then we need to increase our traffic. So for that, this Kubernetes will work. They will create this. They will create one YAML script or a configuration file. In that they will define, okay, we need 100 replicas of our containers. Okay, so normal day, if traffic is normal, then this 100 replicas of container is enough. But let's say suppose tomorrow is match, then we require to increase that container so that easily our app can handle that amount of traffic. So for that, in a YAML script, I will write a configuration that I required 4 replicas of our container, and then these replicas should increase when the traffic is increasing. Means we want to perform a load balancing. Means distribute the traffic between the containers to handle more requests. So four containers are enough to handle hundreds of users. But let's say suppose we have thousands of users. Then in that case, we are not going to manually create one by one containers and go just go there and on a time like, okay, after 1 hour we have a match. So okay, my developer is going to sit and just increase the increase the containers and so that it will handle the traffic. No, it will all automatically. I just write a configuration file. I need 1,000 of replicas of my containers so that hundreds of users, 1,000 CR, whatever the amount of users will hit my app, it will automatically increase my container so that everyone gets a smooth experience of our match. So this is how a Kubernetes works. So define your application, write a configuration file as I mentioned. It will be in a YAML or JSON script that describes how your app should run, how many replicas, which container image or to use, then deploy. Use to kubectl command tool to apply configuration the Kubernetes cluster. Kubernetes will then deploy the application across the available nodes. Then manage. Manage means Kubernetes continuously monitor the app. If any load balancing means if let's say suppose any container goes unhealthy, then it will automatically restart and place the new container on that place so that it will not showing that they are like users are not getting anything wrong on their platform. Okay, next is cloud computing. So you know about AWS, Azure. Okay, so if you are a DevOps engineer or anything, or if you are a developer, you are a tester, you should know a cloud computing nowadays because everyone is using a cloud. There is nothing as a data center or on-premises server. Even I'm in my company, I'm working for the one project where they have it's the UK's one of the biggest marketing company. So they have migrate their own whole database from on-premises to the cloud. Means they have one on-premises server from day-to-day jobs and day-to-day data. It was stored in a database which is on premises, but due to the costing and it's not possible to maintain this. If you want to manage a database, you really require this kind of surface or this kind of room to store that databases. So it's not possible. And let's say suppose tomorrow this anything happens, fire, anything happens, this will destroy the whole database or whole distribute. Means we are not. It's not easy to manage this and manually. So for that, everyone is now shifting to the cloud computing. So cloud refers to the delivering computing service like storage, server, database, network, software, and more over the internet. Instead of owning a physical hardware or managing the data center, so business can rent these services from a cloud provider, access them from anywhere with the internet connection. So services are like storage, computing, database, email service, anything. Like if you want to create any server, you have a HTTP instance server, and also means we have a if you want to storage, create a storage, you have a storage devices, computing, then database. If you want to create any database, you can just use the cloud computing for it. Then key characteristic of cloud computing. One is on demand, like user can access computing resource as needed without human interaction with the provider. And scalability, easily scale up or down based on the workload. Cost efficiency, pay for what we use instead of purchasing a physical infrastructure. Global reach, services are available from the data centers around the world. So these are different cloud services. You all are heard about it. Let's go one by one. Infrastructure as a service. Provide a virtual computing resources like virtual machines, storage, and networking. You manage the operating system, applications, and data while the provider manages the infrastructure. First is like EC2 instance. In Azure, we have virtual machines. In GCP, we have computing engines. So it's the infrastructure. They provide us the infrastructure which is in a virtual form. We are not able to see the server, but it is in a virtual form. We can use it whatever as per our requirement. And platform as a service provides the platform to develop, test, and deploy the application. The infrastructure is managed by the cloud provider, and you focus on your application. So Google App Engine, Microsoft App Service, AWS Elastic Web Service, whatever the infrastructure we require to develop our whole project or whole system, we don't require to create manually. It will just select the services which is available in the cloud. That means in AWS or Azure or Google App Engine, it will provide us an infrastructure. Then software as a service. We are already using a Gmail, Google Drive. These are some software which are already provided by the cloud providers. So these are some famous cloud providers available in the market. AWS, I think it's one of the famous, and it's microservices, Microsoft Azure. Then GCP, which is the Google, it is provided by Google, and IBM has also its own cloud, and many small companies has also its own cloud. But mainly in industry, we use these four clouds for the operations. Okay, so this is one of the architecture. If you see, this is the AWS services. AWS is the cloud provider which provides different services to use. So this is the one basic infrastructure we can see. So if you see, first of all, the end user, then the Amazon Route 53 CloudFront. Again, it is come from the Amazon application load balancer, EC2 instance, S3, and CloudWatch, and then this is the database service. So how it works? Okay. So first, if you are a user, you are going to hit any URL, any web server using the website. Okay, so this website needs to be provided by some domain provider, right? You know about the GoDaddy and all. So these providers are nothing but the Amazon Route 53. So this Route 53 provides a domain from the by using the AWS. If you are AWS, if you are a cloud AWS cloud, then you can buy a domain from Amazon. It has some costing. So according to the costing, we can purchase a domain. So if you search, if you have an address, IP address 192.192.2.2, this is the address, IP address. So end user is not going to use that IP address. It should have some proper name. So this Route 53 will help us to get some domain name so that end user can easily remember it and access it. So then it goes to the CloudFront. CloudFront is nothing but your website is hosted in India, but if you want to address the user which is placed in a USA or UK, so in that place, this CloudFront will provide you a global access to your website. So this CloudFront is also provided by the uh, Amazon Web Service. So next, this is the server infrastructure. Means your application is hosted on this server, but this server is not directly accessed by the Amazon means end user. So what it will do? It will use an application load balancer. So this, as its name implies, it's load balancing. Means if you have three users, which is enough for to handle one server. But let's say suppose if your application goes increase and if you have 10 users, so this one web server or one EC2 instance cannot be like enough to handle this kind of load. So in that case, this application load balancer comes into the picture. Means this application load balancer will automatically create replicas of this EC2 instance. If you have three EC2 instances, it will increase automatically a fixed instance so that these users can access it and that load and traffic get distributed. If load goes from is so it will automatically just destroy the other three instances. It will be keep only three instances so that we don't have much more costing for that. After that, this is the storage. As I see, Amazon S3. This is the storage services provided by the AWS. So whatever, if you want to get any data from the user, if you want to store it and use it for your different use case, then you just create Amazon S3, create inside that EC2 instance. You can just configure it with the Amazon S3. Whatever the data comes, it will store in the Amazon S3 bucket. So next is CloudWatch. So CloudWatch is nothing but it's a monitoring tool which is provided by the AWS only. So it will see if your EC2 instance health is proper or not. Let's say suppose okay we have a load balancer, that's fine, but sometimes it happens like your CPU goes above 90%. In that case, there might be chances of crashing of your EC2 instance or a server. So in that case, this CloudWatch will continuously monitor your EC2 instance. It will provide us a, a alarm that okay your CPU we need to manage it. We need to define that alarm. So it will just continuously monitoring your EC2 instance. Once if your CPU goes 90%, if your storage goes 90%, it will automatically gives us a sign or through email or anything, and so that we can act on it before it goes down. So it will not affect on our application. Then this is nothing but the database thing. So Amazon RDS is a relational database which is provided by the uh, AWS, which is for that we also not required to create any database. We have a relational database. We just need to define a table. We have a database. It will again manage. It will again connect with the EC2 instance, and then we get whatever we require from the database. We can store it and use it as per the requirement. Then as an infrastructure as a code. So this is also one of the DevOps tool. Okay, we like if you are a DevOps tool, a DevOps engineer, you need to create infrastructure using the any cloud platform. It's not like that you need to create it manually. So that let's say suppose if you have infrastructure of 100 users, 100 software, you need to create a software for the 100 requirements, 100 clients. For that, we required to create different AWS tools, AWS services without manually. For that, we required infrastructure as a code. So, infrastructure as a code is the management of the infrastructure, but in a descriptive model using a same version of as a DevOps team uses of a source code. Infrastructure as a code evolved to solve the problem of environment drift in the release pipeline. That means for that means I want to create a services in a AWS, which is S3 bucket, EC2 instance, the application load balancer, which is we have seen here. Okay, I want to create all these services. Either I create it manually just by logging in AWS. I just create it manually, but I don't want to create it manually because there are might be possibilities that okay today I have created it, but tomorrow I forgot whatever the configuration I have made in it. For that, and let's say suppose I just left my job and another DevOps engineer comes. So he just want to again do some configuration and create new AWS services for the same project. Then he just need to see one by one infrastructure what the configuration he has done. Might be there are some manual, might be there are some documentation, but because of the manual fault, there might be some fault in the configuration. So instead of to avoid this, we are using this Terraform as a which is a scripting tool which is used as a infrastructure as a code. So Terraform is an open source infrastructure as a code tool created by the HashiCorp. It enables users to define and provision a data center infrastructure using a high level configuration language known as HashiCorp configuration, which is a JSON actually. So this is the so basic operation of this Terraform is like this kind of script in a JSON format we can write. Instead of go to the AWS console, create it manually, we can just write this kind of script. Means provider is AWS. Means we want to create a infrastructure of AWS. So we just need to mention provider is AWS. Then if you want to create it for the GCP, you need to write Azure or a GCP. So then region, they have different region. Means US East 1, US East 2. These are some regions which is available in the AWS. Then I want to create an EC2 instance, which is a server. So I will write resource AWS instance, which is the name of this EC2 instance, which will be the example. Then AMI. AMI is the OS thing, which what Amazon Machine EMS means. We have different OS is available. Windows, Ubuntu, with Linux. These all are some AMI machines or Amazon machine image IDs available in the AWS. So then instance ID that T2 micro. This means we want this is T2 micro is the smallest level of CPU. If you want more, then T2 micro, T2 large. So there are some different instance type which is available in the AWS. Then it's the type means I want to give the name of my EC2 instance is my EC2 instance type. So this is the basic simple thing, simple JSON, which is used to create the infrastructure in a AWS. Then next is how it works. Means okay, we have write this script in a JSON, but we want to apply it. So for that, first of all, we need to run the command like Terraform init. For that, we need to install the Terraform first. Terraform init, then Terraform plan. Whatever the plan we have written in the last slide, this. So this is once we run that Terraform plan, this will show okay. These all are some these all are some services are going to create. We are satisfied with the plan, then we just need to run a Terraform apply. It will automatically create AWS services in the AWS console. And easily, if you want, instead of if you manually create it or manually destroy it, then we need to go in EC2 instance, then S3 bucket and application load balancer. We need to go it one by one in a console. But if you are written in this JSON file, if you just apply run this command Terraform destroy, it will automatically destroy the whole infrastructure at a one. Next is configuration management tools. Similarly, as we have seen that if you have created EC2, 10 EC2 of instance, but we need to install let's say suppose any database in it or anything like let's say suppose we want to install a Git or a Terraform in it, but we cannot do it manually. Right, 110 is fine, but if you increase the EC2 instance at around 100, it's not easily possible that just go to the every EC2 instance and then create it just install the every database in each server. So in that case, this configuration management tools will help us in a DevOps. So configuration management tools are software applications that helps automate and manage the configuration of servers, applications, and other IT infrastructure. This is a crucial for maintaining consistency, reducing errors, and improving efficiency in a management IT environment. So this configuration management tool is Ansible. Means most of the company uses this Ansible. So there are different configuration management tools available in the market like Ansible, Shape, Puppet, but most of them are using Ansible. So one of the popular tool is Ansible. Ansible is an open source automation tool used for the configuration management, application deployment, orchestration, and task automation. It simplifies complex process and helps streamline IT operations by automating respective tasks across the various system and environments. So we can just write any this kind of script. Suppose we want to install a Microsoft SQL server in 1000 of EC2 instances, means 1000 of servers. So you are not going to just log in 1000 of EC2 instance or a server manually and install it. So instead of that, we just write this kind of JSON file where first is name install Microsoft SQL, host is Microsoft SQL. Replace it with your target row. Means host is I want to install this in a particular EC2 instance or a server. So I will return that becomes it yes. Then task is add Microsoft repository, means it will download it. This is repositories are available to download any software or any SQL databases. So this will use this repo. It will automatically connect to the Google, search this repository, just download it, and it will place in that whole 1000 EC2 instance. Then install the required packages. Okay, we require to install this kind of curl, GNUPG, and FTP transport HTTPS. So these all are some packages we want to install in the 1000 of servers. So it will just once you run that this, it will automatically just install all these things in the one go. Same thing for the Microsoft SQL. So basic operation is to without manually installing one by one, we can just write a script, just run it, and it will automatically install the whole software or packages in one go. So any question for this? These all are not all the DevOps tools. There are different. If you know the Python, it will be definitely a good thing. If you know the data science, it will be definitely good. But along with that, if you know this all these DevOps tools, these all are some basic and most used DevOps tools in the industry. But if you want to learn more, you should know the Ubuntu, Linux command, then Python. There are different scripting languages. So for that, there are different things you need to, commands or different tools you should require. So any questions on that?
So at the starting, you told that there are the two methodologies. One is waterfall and agile. So when it is compulsory to use only agile methodology, how the different decide which methodology?
Mostly in industry nowadays we use agile methodology. because it has a smaller